It's recording. I'm going to trust it. All right. Amanda, ready? Ready to go? Thank you. All right. Looking at this, we're going to learn something called the binomial theorem. We know what binomials are. It has two terms. Binomial, like a bicycle, two terms. And what this is going to allow us to do is take any binomial, let's say it's an easy one, x plus 1, and we could figure it out for the 9th power without having to do, x plus 1, x plus 1, x plus 1. I don't even want to do it. We don't have to write it out 9 times and then multiply one at a time, distributing, like 36 times. We don't have to do that. We can use Pascal's triangle, which we explored yesterday, I thought, pretty well. A little bit of mind-blowing yesterday with some of the things we can find with Pascal's triangle. We can figure out how to work out something like this, a binomial to the 3rd power, using Pascal's triangle. That's what I'm going to show you today. Okay? It's going to be pretty quick with our steps. We're already familiar with Pascal's triangle, and there's a bit of a process with the steps, but by the first example, I think everyone will be about here. By the second example, we're going to be closer to being experts. Yeah. So,
Can you do that?
oh yeah. No. Now the one thing here, these are our rows. We already know that. That's denoted by n, the number you're on for the row. And row 0, you guys know that's the one on top. It starts at 0. The same thing with terms. The term on the very left is 0, and then it adds up going the other direction, going to the right. And that is our k value. Just got to have that in your notes. I won't bring that up again right now. There's some applications to what we're doing that involve combinations and permutations. That's not for Math 3, but I need you to know this is our k value, and that's in because it's going to be used again when you do combinations next year or whenever you touch it. Okay. So here's the deal. We know how Pascal works, and what we're going to figure out is that if it's to the 3rd power, I go to my 3rd row, and these values that are in the 3rd row are my coefficients. Remember, the coefficient is what's in front of, it's in front of my variable. The coefficients are all perfectly laid out for us. If it was the 3rd power of a binomial, then I would use these for my coefficients. So we can see it that way, that's going to help us with our coefficients when we expand this. The hardest part is inputting the exponents. But after you see it twice, you'll see there's a nice pattern that happens every time, every single time. This works every single time. It makes it much easier than having to just kind of push through it and expand everything one at a time. Okay. So let's look at steps 1 through 5 for example 1. Okay. First off, my a and my b values are just each of the terms in my binomial. Remember, binomial, bicycle, binomial, 2 terms. So which is my a value up here? What's my a value? X. A is x. What's my b? 2. It's just whatever's there. And since it's a binomial to sum in, it's just whatever terms are in there are my a and my b every single time. Okay. So we have a and b. So we got step 1 done. Find the row based on the exponent. So looking at our rows here, how do I know what row to look at? What did we just learn? Exponent. What's our exponent up here? 3. Our in value is 3, right? So that tells us that our row we're going to look at is row 3. So this row right here, these are going to give me my coefficients to write this whole thing out. This expanded out into a bunch of terms. So watch what I'm going to do. It's 1, 3, 1, right? 1, 3, 3, 1. So what I'm going to do is put this down. I'm going to put 1, and then I'm going to put space for my a and my b. So everybody go ahead and write this with me. 1, then the space for your a and your b. Plus 3, because that's the next number in my row 3. So I knew that this would be my first coefficient. Now this is my second coefficient here, 3, and then space for a and b. You could label it like that if you like. Oh, we can fix this. Yes. What's my next coefficient going to be? I did 1, I did 3, what's next? 3. Plus 3, space for your A and your B. Plus 1, space for A and B. All right, looks like we're going to have to erase part of this because I'm going too far over. Okay, is everyone okay with how I found those coefficients? We know where to look, right? We know it's the third power. Our in value is 3, so I look for my row 3. 1, 3, 3, 1, 1, 3, 3, 1. It's pretty nice, right? A lot less work than we had to. This is the hard part, right here. This is the hard part. What we're going to do, we need to put our exponents for A and B for each of these, right? Because as we multiply, if we were expanding this out, if you did FOIL, you could think of this as FOIL, x plus 2 and x plus 2. You're going to end up with an x squared, right? You're going to end up with an x squared for your first. So there's going to be some exponents for A and B for all these terms. And what we're going to do is we're going to put the A exponents in red. We're going to put the B exponents in blue. Now, I'm going to start with my A's. The A's, the highest exponent I'm going to end up with is 3. So watch what I do with my A, the first term. I'm going to put a 3. And then if we look here, I look and see that the A, what happens with it? 5, 4, 3, what's happening? 2, 1, 0. It's descending. The A exponents descend. So I have 3, then what? 2, 1, 0. The A exponents descend. From this, what's going to happen with my B exponents? Ascend. So we start with 0, 1, 2. We just set up the structure for this whole binomial expanded out. The only other step is step 5, and that's to evaluate, which means plug in. And then I need to simplify it. So I look to this. I know my A value is x, so go ahead and put x everywhere you see an A. X. X. Okay? Go ahead and put the 2, which is my B value, everywhere there's 2. 2. 2. 2. 2. Is anybody looking at this and kind of waiting for the ta-da to this? But it sets it up really nice. I mean, now we just have to simplify. And watch what I'm going to do. This is for folks that maybe sometimes mess up with the exponents. This is what I want you to do. Remember the accordion, we can expand it. If it's multiplied, we can expand them all out and then compress them all back. So watch what I'm going to do here. I'm going to go ahead and 1 times x times x times x times what's 2 to the 0 power? Anything to the 0? 1. You guys got it. You see, you remember when I expanded like this? We expand them all out. They're all multiplied. I can expand them all out and then compress them all, simplifying this. We'll do it for each, and then you'll see we'll get the final answer pretty quick. Okay. 3. How many x's?
2.
How many 2's?
1.
Perfect. Same answer. 3 times x times 2 times 2. What's this one? What's that going to be? X to the 0? 1. 1 times 1 times 2, 2, 2. You see, if I have them all expanded out, then when I now compress them back, I have my final answer and I'm done. Right. So we're almost done already. So 1 times 1 is 1. I do the numbers first. That helps me. And then x times x times x, x to the third, plus 3 times 2, 6. How many x's? 2, because they're multiplied. Remember, that's x squared. Plus 3 times 2 is 6, times another 2, 12 and x. 1 times 1 is 1, times 2 is 2, times 2 is 4, times 2 is 8. Done. Who loves Pascal's triangle now? Yes. Everyone's hand was raised. Everyone. Talking to the people. My devoted subscribers in Brazil. I don't know Brazilian. Sorry. I have subscribers all around the world. You know Portuguese?
Portuguese, because that's what they speak in Brazil.
I know. I grew up There's a lot of Portuguese in the area of LA I grew up, actually. Absolutely not. My Spanish is bad enough. I'll figure something out. I'm going to surprise you one day. I'm going to talk to my Afghan subscribers. That'd be special. How do we feel? Thumbs up, sideways, down at this point. At this point. Okay, it's okay. Yeah. We have one more example. We see it again. What's the hardest part? Who can verbalize if they're kind of side? Yeah, what's the hardest part?
It's that whole simplifying after you put it in the
From
simplified
here
form.
down. From here down.
Yeah.
From there down.
Yeah.
Okay. So the reason I do this is, remember these all multiplied, so you can choose to multiply any together at a time. And I say 3 times 2. That's my coefficient. X times x, remember that's the definition of a squared. While x times x times x, that's the definition of a cube. Remember, exponents are just multiplying the term by itself that number of times.
Okay.
Yeah, clarify. And
I think the hardest part is like remembering like the coefficients for like A and B, like remembering this descending.
those aren't coefficients. These are coefficients. What are those?
Powers.
Powers, exponents. Good. Degrees, a lot of ways to say it. So we're going to do it again. I think you'll see it's just a pattern you have to get used to. It's more something to get used to. When you start to use it, it's not the hardest part. I think the hardest part is going from here to here. So we'll see, though. That's my guess on that. All right. Let's turn everything to the left. Who's having a hard time seeing because of the glare? Anybody? A little bit, huh? So I'll just close the door. Maybe that'll help. Andy, can you pull your curtain a little closer?
Oh, this one?
Yeah.
Yeah, I got you.
That's a little better. All right, so let's start with step 1. What's my A? A is 3x, and this is different than what I taught last week, because last week, remember, the properties were up here. We had the properties, and there was one if it was like a cubed minus b cubed. We didn't look at that minus. That was part of the structure of the difference of cubes. In this case, with this binomial, my b value is equal to negative 2y. So this is one sec. This is I have one thing to say, and I'll take your question. I want you to put an arrow to this negative. I just want you to write negative, because this is a key place that folks make mistakes. It is the entire term with the sign. What am I missing?
No, it's because the glare was on the first.
3x?
Yeah.
Gotcha. Step 1's done. 1 done. 20% done. Find the row based on the exponent. What's my exponent in this case? 4. So I look back over here. I look to my 4th row. Just real quick. Look to the 4th row. I'm going to use 1, 4, 6, 4, 1 as my coefficients. It also tells you how many terms you're going to end up with. So I'll go back over here. Field trip for the people at home. That works. All right. I'll try to draw bigger. Okay, so watch what I'm going to do. I know I'm picking the row. It's row 4 because I have the 4th exponent, the 4th power up here. 4th power, 4th row. Write out the coefficient. So let's do that. For 4th row, we have 1 times an A and a B plus 4 times an A and a B plus 6 times an A and a B plus 4 A and B plus 1. Everybody got that step? Got that step? All right, now this is the part a few have suggested is the trickier part for them. So I'm going to go ahead and circle. A is going to be in red. B is going to be in blue. And first off, what is the highest degree of my exponent that I can have for this problem? 4. The highest degree, if you're wondering where to start, what to put on my A term here, it is always going to match what you have up here. If this was to the 7th, I would start with the 7 here. But since it's to the 4th, I'm going to start with the 4th 4 here. Okay. So looking at that, I'm going to go ahead and do 4, and then what? Let's just do the ones.
Yeah,
You're
okay,
right. Let's do
3,
these. 3,
2,
2,
1,
1,
0.
0. And notice how those exponents are all aligned with the first parenthesis, which are going to be all my A terms I'm going to put in there. Okay? I go in there now with the B, and let's see. Somebody help me out. What should I put in for my first number here? 0, right? The A's go down descending order. The B's go up ascending order. 1, 2, 3, 4. Okay. We have the whole structure ready. Now this would be the structure you'd set up for any binomial to the 4th power. So, you know, if I wasn't really teaching you guys very much, I would just write these out and say use this if it's a 4th power. Then I would write out the 5th, use this as the 5th. But now you see the steps to do it, right? You could do this on your own from nothing. So what is my next step? Input the exponents, then evaluate. That just means plug in. Evaluate means plug in. So what should I put in for my A values? 3x, 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 and again, 3x. How about for my B value? Negative 2y. This is going to get a little tricky. That's why I gave you a negative. Okay. And then I'm going to actually rewrite everything over. I'll just move it over a little bit. So everybody get those in there. You got your B values in. Got those parentheses set up. All good. Great. All right. I'm just going to move it over so that I can draw it right a little bigger. And I'm going to expand it out first. If you know how to go, you know, there's no place where it's going to be really tricky, but I want to expand it so you get used to doing that. You don't have to. If you can just go from here to your final answer, perfect. But let's expand it. 1 times 3 times x times 3 times x times 3 times x times 3 times x times, what's this to the 0 power again? 1. This, 4 times 3 times x times 3 times x times 3 times x times negative 2 times y. See? Okay. Plus, well, actually I'm going to leave out plussing or any operations yet because the positive or negatives within the term are going to distinguish what is going between the terms. So for instance, this one only has 1 negative, so everything is going to become negative. So it's going to end up being subtraction between these terms. So we'll keep that to the end though. Don't spoil the surprise. 6 times 3 times x times 3 times x times negative 2 times y times negative 2 times y. That's going to make the whole thing positive. Right? So we want to make sure that you pay attention to the signs within the problem. Next, and I think I'm going to have to kind of stagger this. 4 times 3 times x, and then we have negative 2. I'm just going to put the negative 2's together. Everyone okay with that?
Yeah.
So just negative 2's multiplied together times y times y times y. Again, this is the foolproof. You will never mess up as long as you expand this. It's like an accordion. Never goes away. Nothing disappears, comes back. All right. Lastly, we have 1 times, what's 3x to the 0? 1. So don't get confused. Yeah, Melissa.
So it won't be, like, for example, like the first one, it won't be like 1 times 3x times 3x.
You can do it that way. I did it even more to bit smaller pieces because 3x is 3 times x. So if you see it that way, just fine. Keep it that way.
Same as like times negative 2y.
So we did exactly the same thing. I just expanded it even further, which you don't have to do. Okay. I'm just going for the max scaffolding I can give you. This is the way that if you're having more trouble with this, this might be the way to break it. Okay. Anything to the 0, 1. Then we have negative 2. I'm just going to leave it like Melissa did. That's fine. Negative 2y, negative 2y, negative 2y. It may seem like a pain in the butt right now, but if you try to expand this where we were just taking the beginning problem and making it, you know, all the way out, this will take you twice as long to figure this out because you have to FOIL this one and then FOIL this into those 3 terms and FOIL this into those 6 terms.
You can't FOIL both pairs of them.
Sorry, you could FOIL both pairs, but then you would have 2 trinomials. You'd have to FOIL. You'd have to distribute first term, second term, third term, and then come. So let's use the binomial theorem using Pascal's triangle because, you know, Pascal didn't even make it up, but he takes credit.
Mm-hmm.
And that means nothing.
I'm sure.
All right, now we're going to put it all together. Okay, help me out. 1 times 3? 3. Times another 3. I do all the numbers first to get the coefficient. 9 times 3? 27 times 3? 81. 81, how many x's do we have? X to the 4th, good. We're going to leave the sign out because the terms multiplied together will give us the sign between the terms. So let's go with 4 times 3, 12 times 3, 36 times 3, 108 times negative 2, negative 216. You can use your calculator for that. How many x's do we have? 3. How many y's? Right. All right, next. Let's see. We have a negative times a negative. Negative 2 times negative 2. Positive. Positive 4 times 3. 12 times 3. 36 times 6. 181. 216. Positive, right? How many x's? 2. How many y's?
2.
Got it. Not bad, right? We break it into smaller pieces. We can handle any little piece. All right, right up here, negative 2 times negative 2 is positive 4. Positive 4 times a negative 2, negative 8 times 3, negative 24 times 4, negative 96. I think 25 times 4 is 100. You have 1 less from each of them, so 96. All right, 1x, how many y's? 3, good. Last, then we're done. Negative 2 times negative 2, positive 4. Times a negative 2, negative 8. Times a positive, negative 2, 16. How many y's? Done. Somehow, it's a shortcut though. You want me to show you fast forward the other version? It's horrible. Thank you. Alright, for those at home, my new super skill. I am posted, man. That's right. That's right.
Beware.
Beware.
Don't fall for his tricks.
Don't do it. That didn't work. That wasn't even funny. Alright. But you know what is funny?
What is
Baby sharks. And you know what is kind of weird? It's weird that there's kids ready to come on down. Come on down.
Do it.
And anybody? I thought you were all excited.
I am willing to sing.
Come on, Amanda.
Yeah, it's voluntary. It's not mandatory. All right, so if you're on the blue lines, you're not in the camera. So we will go ahead and... All right, here we go, basketball players. Uh-oh. That's right.
Saying run away. Oh dear.
All right, subscribe on 3. 1, 2, 3.
Subscribe!
Thank you guys. You guys are the best. You at home, good job too.